What's up, class? Let me first say welcome back from you guys. Long break. Hope everybody's safe. Hope I know everybody's power wasn't out and whatnot. But what we're gonna do is we're gonna go ahead and start talking about transformation, which you guys should have went over the last time you was in school. So you guys had this worksheet on, I think it was that Monday. And so what we're gonna do today is basically just go over it, and then you guys are gonna have some practice, some extra practice on transformations. Okay. All right. So the first part of this worksheet is we know the parent function, which is y is equal to x. We know that's the linear function, y equal mx plus b. We all know that. So what you guys are supposed to do is basically graph the parent function, which is this one right here. All right, y is equal to x. We know input, output. We input our x values to get our y values. You guys should have that graphed, okay? So make sure you guys have that graph. So after that, what you're going to do is graph number 3. Okay, y equal x plus 1, you know, same thing, input, output, or you can also do what, guys? You can do use slope-intercept form, graph your slope. Graph your y-intercept, then graph your slope. Okay? So what I want you to start seeing, guys, is what's changing every time you're basically graphing these functions. Okay? So if I'm looking at this, the first one, y is equal to x, and the second one, y is equal to x plus 1, what just happened to this graph? What's the transformation that happened? It just shifted what? Up. 1. That's what this little piece right here means. Okay, this little piece right here, when you're adding or subtracting something to that parent function, so all I did was just added a 1 to it, that means I'm shifting up. Okay, this means shift up. Alright, so anytime you see something you're adding or subtracting to a parent function, which is y equals to x, which is this one right here, okay, you're going to be moving up or down. Now, if it's positive, of course, you're going to move up. And if it's negative, you're going to move down. Okay? Just that easy. All right? So let's go to the second one. Okay. All right. So as we move down, we see 4 and 5. Okay? Now, just what I talked about, for 4 and 5, the parent function we know is y equal to x, which is only the top part of your worksheet. So you see for number 4, you have minus 1. What's happening to this function now? It's shifting down. Why is it shifting down, guys? Because we know, if we look at this, it has minus 1 to our parent function, which is y equal to x. So in this case right here, we know we're shifting down. That's the transformation. It's shifting down. Okay? All right. Now let's look to number 5. Number 5, we know it's shifting what? We're looking at this right here. We already know, automatically know it's shifting up, but something else is happening. Something is changing in this. We see a negative right here. Okay? Whenever you see that negative, guys, you know you're reflecting. If you look at think of reflecting, you think of a mirror. You look in the mirror. I know Smurf look in the mirror and just like, dang, why I gotta look like that? But if I'm looking in the mirror, that's your reflection. Okay? So all it's doing is it's reflecting over the x-axis, okay? And you can get some more practice in this, of course. But in this case right here, it's reflecting over the x-axis if you see a negative, okay? It's reflecting over the x-axis. That's all it's doing. All right? So let's move to the next one. So let's go. Let's retrack real quick, okay? Backtrack a little bit. We know that if we're adding or subtracting a number to our parent function, you know you're going to be doing shifting up or shifting down. Okay? If you see a negative, that means you're reflecting over the x-axis. Okay? So let's move to the next two down here. Okay? Now you're going to graph the function y is equal to 2, x minus 1. Now something's changing. Something's changing in these two graphs right here. We automatically know what? We're shifting down by 1. But what does that 2 mean? What does that 2 mean? Okay? That 2 in front of your x is also talking about another transformation. It's talking about shrinking or stretching. Okay? Shrinking or stretching. All right? Now, what you want to look at is the slopes, okay? 2 and this 1/3. Okay, now don't worry about the negative right now. We're just looking at 2 and the 1/3. Okay? Now, if you see, if that number is greater than 1, then you should be, now, sorry guys, now if that number is greater than 1, then you're going to be stretching. When you think stretching, think of a rubber band. You're pulling a rubber band. When you pull a rubber band, it gets skinny. It gets real skinny. It gets long and skinny. Okay? So if this number right here is greater than 1, then you're going to be stretching. Okay? But if this number is in between 0 and 1, which we know 1/3 is in between the number 0 and 1, that means it's going to be shrinking. And when you think shrinking, guys, think like you're flattening something out, like you're flattening like a pancake or something. Just think like you're flattening like Play-Doh out or something. That's what that means right here. This means you're flattening out, because this number is in between 0, okay, and 1. It's in between those two numbers, okay? And so we know it's in between 0 and 1. 1/3 is, we know it's going to actually be shrinking. When we say think of shrinking, guys, think of flattening out, okay? That's what that means, flattening out. Again, if that number is greater than 1, we know it's stretching like a rubber band, okay? If it's in between 0 and 1, you know you're flattening it out, okay? All right, so what you're going to do is you got about 5 minutes. Miss Yamini, I'm sorry, not Miss Yamini, Miss Jones and Miss Campbell, they will pause the video. Give them a second to pause the video, and you guys will answer those 4 questions, okay? Go. Okay, now that time is up, guys. These are basically the answers here. We already talked about this. If a number is added or subtracted to the parent function, which was, again, was y was equal to x, if you see an addition sign, that means you're moving up. If you see subtraction sign, that means you're moving down. Okay, shift up, shift down. Let's go to B. A negative is in front of the parent, then we know we're reflecting over the x-axis. If you see that negative, okay? All right, for C, we just talked about this. We just talked about this. A number is greater than, you know, that means greater than 1. All right, that means you're stretching. You're stretching like a rubber band, okay? Now, if a number is less than 1 but greater than 0, it means it's in between 0 and 1. Okay, that means you're shrinking. You're flattening out. The graph is going to flatten out. Okay. All right. Make sure you guys have this copied down, because you're going to need this for your next assignment. All right. So let's move to the next one. All right. So now we're moving to exponential functions. We know curved exponential functions, what we just talked about. Okay. So now this is our parent function right here. This is where we're going to start from. Y is equal to the x. Okay. Now looking at this one, go number 11. What does the graph do? Same thing as it was with linear function. You see, if you're adding or subtracting a number to that parent function, like we're doing right here, we're shifting up by 1. Okay, you're shifting up by 1 right here. Okay, all right. You see, everything shifts up. Your asymptote shifts too. Now your asymptote becomes 1. You guys remember this from, again, when we was graphing exponential functions, so it should not be a problem for you guys. And you see, we're actually using the same points. Okay, all right. So there you go. We know we're shifting up. All right, let's move to the next one. Okay, now we have 12 and 13. Something just a little bit different. Now, you haven't seen something like this before. You guys haven't seen where you're adding or subtracting a number, okay, to the exponent. Okay? Nothing changes, but you just got to remember, this means you're shifting left or right. Okay? Left or right. When you see a number adding to the exponent, you're shifting left or right. Now, how do you determine that? Think opposite, the opposite of what you see. So right here, you see a -3, right? We see a -3 right here. So what you think is you shift where? Left. No. That is wrong. Okay? You're not going to shift left in this case. All right? What we're going to do is we're going to shift right. So think opposite. Let me put that right here. Opposite. Okay? Think opposite when you see you're adding a number to the exponent. Okay? All right, so in this case right here, you're going to shift to the right 3 units. Okay? Shift to the right 3, because you see that -3 up there. Okay? So nothing changes that. Asymptote is still the same. Everything's still the same. But you're only shifting to the right 3. All right, so let's look at this last one. Number 13. Now, In this case right here, you're shifting where? To the where? Left, right? Good job, good job. You said left, Isaiah, you're right, okay? If you said left, you're right. All right, so good job on that one. So we're shifting to the right 2, because you want to do the opposite. But what's going on with this right here? Now you have a negative. We just talked about for linear functions, if you see a negative in front of your parent function, you're going to reflect over what axis? The x-axis. The x-axis is this one right here, right? X-axis is this right here. So the graph was actually pointing up, and it just did what? Pointed down. Reflected, okay? Reflected over that x-axis, okay? Like I told you, Smurf, just like you look in the mirror sometimes, you're like, dang, okay? Reflect over that x-axis, all right? Okay, so 5 minutes again, guys. On your own, I want you to answer those questions at the bottom, okay? Go. All right, so again, we have added or subtracted to the parent function. We adding, it's going shifting up or down, okay? At the end, the key word, and I like the way we highlight this right here, at the end, okay? A number is added, subtracted to the exponent. We just said that. You're going to think opposite. Opposite. But we know we're shifting left or right. Okay, C, a negative is in front of the parent function, reflecting over the x-axis. We're good on that one. Now, let's go back down here. Okay. When would an exponential function stretch or shrink? I'm sorry. Same thing. All right. It stretches when it's what? Greater than 1. We know stretch is talking about a what? Rubber band. Okay. Rubber band. Shrink when that number, A, is less than 1. And when we're talking about A, guys, you know, it was always y is equal to A to the x. So this number here, this case right here, this would be your A. Okay. That means it's flattening out. Your graph is going to flatten out. Okay. That graph is going to flatten out. All right. Make sure you guys have this copy down. Okay. Now, going to give you 10 minutes. No, you only need 10 minutes. Yeah, I'll give you 10 minutes to complete the questions at the bottom. Okay. 10 minutes to complete the questions at the bottom. And we'll go over those answers. Go. All right. Time's up. Time's up. Time's up. Okay. Now, let's look at these. We see for 15, you're adding to the what? All we're doing is adding to the parent function, shift up 5. Just that easy. Over here, what are we doing? We're shifting what? Up 11. Okay, you're shifting up 11. All right, 17. Now we have what? 1/2 in front of that. So you're going to stretch. Is that number between 0 and 1? Yes, it is. So we're going to stretch by 1/2. Okay? Alright? And then right here, you should be shifting up 3. Okay? It just has 5 right here, but yeah, you should be shifting up 3 because you're going from the parent function. Okay? Alright, over here now we're dealing with exponential functions. Now we have what? We shift to the right 1. Because we're doing the opposite, and you shift up 1. Okay? Over here, you see a negative. We see a negative, so you flip over the x-axis. 19, and at the right there it says what? Shift to the left 5, because that is a positive, so you do the opposite. Okay? You have a bunch of stuff going on right here, but you see, okay, first thing you have a negative. Negative, flipped over the x-axis. Now you have the number in front of